Chapter 10 is all about chemical bonding. Why do we even care about chemical bonding? In 1989, researchers were able to find the structure of HIV protease, which is an enzyme that is needed for HIV to reproduce and cause illness. And bonding theories were then used to simulate how potential drug molecules would interact with this enzyme. So over here we have this representation of HIV protease, and they were able to try, on a computer, try some different molecules and see how they might interact. The way enzymes work is they have an active site, and if you can design a drug that will fit into their active site, it will block their action. And that is one way to disable the virus, and they were actually very successful in this. They developed a drug called indinavir, which is a protease inhibitor, and that's indinavir in here. It's much faster if you can kind of narrow down the possibilities by looking at how these molecules would interact with this thing you need to interact them with. And understanding how molecules bond and interact with each other is very important in this. So bonding theories, remember, a theory explains why behavior occurs, not just what happens. So bonding theories predict how atoms bond together to form molecules. They're going to predict what combinations of atoms will form compounds and what combinations do not. So instead of trying to, get sodium and magnesium to interact with each other and form a compound, and trying lots and lots of different things and failing, you can look at bonding theories and predict that sodium and magnesium are not going to form a compound, and in truth they don't. It helps us to predict formulas of compounds, and it explains shapes of molecules. Shapes are important because many of the physical and chemical characteristics of compounds have to do with their shape. Lewis theory is the simplest theory, and so we're going to talk about that one first. It's the simplest theory for making quick, everyday predictions about molecules.